So the focus for today is on applying Newton's second law on an inclined plane. So let's consider this situation. It says block P of mass 2 kg is connected to block Q of mass 3 kg by a light inextensible string. Both blocks are on a plane inclined at an angle of 30 degrees to the horizontal. Block Q is pulled by a constant force of 40 newtons at an angle of 25 degrees to the incline. Block P moves on a rough section AB of the incline, while block Q moves on a frictionless section BC of the same incline, as you can see in this nice diagram. An average constant frictional force of 2.5 newtons acts on block P as it moves from A to B up the incline. And the first question is the one I trust you with my life, that you can take care of it. Now the next one says, draw a labeled free body diagram for block P. So we are going to do the free body diagrams for both blocks. Fine. So let's go to the whiteboard for that. Now you have to learn what is the difference when something is on an inclined plane. Well, there's no difference as such, but there's a difference. So if we look at block P, this is how it looks like. Now, here we can see that the surface is not horizontal. So regardless of how the surface is, the normal force is always perpendicular to the surface. It doesn't compromise. Are you fine? So you say this is your normal force there. Now, the gravitational force is always directed downwards towards the center of the earth. It doesn't compromise as well. Now, this is what you have. Then you have the tension force, which is upwards along the incline. Do you see that? Right. So you'll say T there. And because the section AB is rough, so we understand that we actually have the frictional force, kinetic frictional force, to be specific. Fine stuff. Now, what about for block Q? Let's look at Q. So this is how block Q looks like. And then you'll say, okay, once again, the normal force doesn't compromise, so it's going to be perpendicular to the surface. And then you say, there's going to be a force that is acting at an angle, which is the applied force, yes? So you can say it's F applied. You can say F applied on your free body diagram, or you can just write 40 newtons. It doesn't matter, but I'm going to say F applied. Then from this point, you have the tension force because it's being pulled downwards by block P. So this is what you have. It's your tension, but this one is on a frictionless surface, so we don't have friction. The gravitational force, once again, doesn't compromise. It's always directed downwards towards the center of the earth. So this is how it's going to look like. Now, what is the difference on an inclined plane? You have to know that the normal force is not equal to the gravitational force, but instead, it's going to be equal to the component of the gravitational force that is perpendicular to the surface. So here we have a component of gravity that is perpendicular to the surface. Now we also have the component of the gravitational force, which is parallel to the surface. And this is what I have to warn you. In your calculations on an inclined plane, you never talk about the gravitational force itself. You always talk about the parallel and perpendicular component of the gravitational force. So if we look at block P alone, which forces are parallel to the incline? It's the tension force, the kinetic frictional force, and the parallel component of the gravitational force. Now, what about for block Q? Which forces are parallel to the incline? It's the tension force, the parallel component of the gravitational force, as well as the component of the applied force that is parallel to the incline. Do you see that? Awesome. So if frictional force was there, it would have been there, but it's not there, unfortunately. So the reason why this is 8 marks, it's because we still have to resolve this applied force. We have to find its component that is parallel to the incline. Now the question is, which formula do you use if you want to calculate FG parallel? Well, you just take your gravitational force and then you say sine theta. So what is theta? Theta is the angle of the incline, very key. But for your perpendicular component, you say FG equals mg cosine theta. So when resolving this applied force, your theta will be the angle between the force and the inclined plane, which is 25 degrees in this case. Please don't confuse the two angles. Fine stuff. So now we can go and actually do the calculations. So the question says, oh, I didn't show you the question. Yes, 15.3. Calculate the magnitude of the acceleration of block P while block P is moving on section AB. So by now we understand that the two blocks are connected. So we are actually calculating the acceleration of the whole system. That's what we know. And we said every time we must do this, we have to do it by using simultaneous equations. Fine. Now let's tell them that firstly, we are considering block P. So we apply Newton's second law on block P separately. So once again, we say the direction of motion is chosen as positive, which is any force that goes upwards along the incline. So meaning the tension force will be positive, the kinetic frictional force will be negative, as well as the parallel component of the gravitational force, it will be negative. So there are only 3 horizontal forces, or rather forces parallel to the incline. Then you say everything equals MA, like that. Fine. Now we don't know what is the tension force, but they told us that an average constant frictional force of 2.5 newtons acts on block P. So for FG parallel, we said we take the mass, we multiply it by the acceleration due to gravity, then we say sine theta. But theta here is the angle of the incline. Then you say everything equals 2a, like that. Now, simplifying this, what do we get? Well, you say 2.5, negative 2.5, minus 2 into 9.8, sine 30 degrees. So it's going to give you negative 12.3. If you take negative 12.3 to the right, it becomes positive 12.3. And this becomes your first equation. Fine. Then we come back and consider block Q alone. We still apply Newton's second law on block Q. This is what we say. Right. Now, the positive force here, it's going to be the component of the applied force parallel to the incline. So let's call it F in the X. It's fine. Then we say plus. The tension force will be negative, as well as the parallel component of the gravitational force. It's negative. Now, what is F in the X? We know that it's F cosine theta. So in other words, it's 40 cosine 25 degrees. Then you say minus T minus, for FG parallel, well, the mass of the grade or the block is 3 kg, acceleration due to gravity, and then you say sine 30 degrees, like that. Then everything is equal to 3a. So I have to get rid of this free body diagram. I think we should get rid of this one as well, because you've seen how it works. Right. So if you say 40 cosine 25 minus 3 into 9.8 sine 30 degrees, you get 21 point that, and that. So let's write it. You get 21.5523. I think 4 decimals will do. If not, you can write the whole thing. But I'm going to write 4 decimal places. Then we say everything equals 3a, like that. Then from this point, we take t to the other side, it becomes positive. We take 3a to the left, it becomes negative. So it means our tension will be equal to 21.5523 minus 3a. And this is our second equation. So these two equations are equal because they are both equal to t. So we might as well equate them. So you say 2a plus 12.3 equals 21.5523 minus 3a. Then we take 3a to the left so that it becomes positive. So 2 plus 3 will give us a 5. Now, what about 21.5523 minus 12.3? So this one gives us 9.2523. Then from this point, we divide both sides by 5. So let's see. We find that our acceleration will be 1.85 0.046. So let's just take it to 2 decimal places and say this is how it will be. Oh, the question is not looking for tension. It's actually looking for the acceleration. So because they said calculate the magnitude, it means we don't need to assign direction. But if they wanted direction, well, we can tell them it's upwards along the incline. Or you can say up the incline. It's up to you. Fine stuff. So that's your nice acceleration. I see the smile on your face. It's good. Now, what about the last question? This is what it says. If block P has now passed point B, how will its acceleration compare to that which is calculated above? Will it be greater than, smaller than, or equal to? And give a reason for your answer. So they say this block has now passed this point. What does it mean? It means it's now somewhere here. And here we can see that the surface is frictionless. Do you see that? So in the absence of frictional force, it means the net force will now be going upwards. So there's going to be an increased net force. Do you see that? Oh, why am I giving you the reason? Okay, fine. Sorry about that. The acceleration is going to be greater than the one we calculated. Why? It's because in the absence of frictional force, the net force is going to increase. So remember from Newton's second law, if the net force increases, the acceleration is bound to increase as well. Yes, so that will be your answer. But seeing how the reasoning is 1 mark, you can just say there is no friction, or you can say the net force increases. Yes, I think so. So any of those two will actually do. Yes, and so this is the end to this question. Thank you so much for sticking with me so long. I really hope you enjoyed this video as I did, and I really hope it helps a lot.